So hello and welcome back. So in this video I would like to talk about a few terms that are related to exponential functions. So basically we basically talked about the initial value of a function. For example, if you have let's say you have a bank account, and you have a savings bank account. This is n, this is balance as a function of the number of years. For example, you start with the $400 and then you start with $400, and then after 1 year you have, let's say you get 5% interest. You get 400 times 1.05 as the balance of the account, and then after another year you get 400 times 1.05, which is this balance, and not times another 1.05, and after n years you have 400 times 1.05 raised to the nth power. So you see that your function here starts with 400. So this is basically your initial value. And if you did the graph of this function, you would get something like this. Let's say this is 200 and this is 400. And so your function would be something like, it will go through the y-axis at this point, and then it will keep going up like this. Or I don't know, maybe at a slower rate. Maybe the rate is slower, I'm not sure about this, but it's going to be something like this. So this is your function, and this 400 is your initial value because it is the output of the function when your input is equal to 0. Here your x is equal to 0, and your y, let's say this is y and this is x, and your y is equal to 400. So this is your initial value. Initial value of the function. Then, and this corresponds to basically, if you were to write the equation, an equation for this function would be f of x is equal to a times b raised to the power x. And you can see that this a corresponds to this 400. So your a is again here your initial value. And your b here, which I did not know any name for, is called your, of course in the book I guess it's called something else, but this is also valid. It's called the common ratio. The common ratio of the function. And it's been called the common ratio of the function because, let's say you have a function like h of n is equal to 1/4 times 2 raised to the power n. Now here, for example, let's see, h of 0 is equal to 1/4. H of 1 is equal to 1/4 times 2. H of 2 is equal to 1/4 times 2 raised to the power 2. So now if you divide h of 2 by h of 1 here, what you get is 1/4 into 2 raised to the power 2 over 1/4 into 2. So these you can cancel out, and the 2 here can be cancelled out here, so you get a 2 here. So you get a basically the successive basically h of 2 divided by h of 1 is equal to 2, which was this number over here, which we called the common ratio. Now if you do the same thing again here, for example, if you divide h of 1 by h of 0, h of 1 by h of 0, you will get 1/4 divided by h of 1 by h of 0. 1/4 into 2 divided by 1/4. So here you can see that you can cancel these two out, and again you will get the same number. And any basically any successive term divided by the previous term is always going to give you this 2 and 2 and 2 and 2. So it's called the common ratio because it's the ratio between any successive terms in the function, of course in the output of the function. So basically I could simply write it out like this. I could write it out as h of n plus 1 over h of n is equal to, based on this function, is 1/4 into 2 raised to the power n plus 1 over 1/4 into 2 raised to the power n, and then you will always be able to cancel these two out, and 2 raised to the power n plus 1 over 2 raised to the power n is equal to 2 raised to the power n plus 1 times 2 raised to the power minus n. So then this is going to be equal to 2 raised to the power n plus 1 minus n, and these two will be cancelled out, so you will be left with 2 raised to the power 1, which is equal to 2. Always you will be left with 2 in this function, for example. And in this function, this 2 is called the common ratio because you will always end up with this 2. But we will get to some other terms here in the book. Basically, in the case of these such examples here, for example, you have 1.05, and then you can rewrite this as 1 plus 0.05 or something like that. We will get to that later. But this much we can do for now. Okay, so I'll see you in the next video. Thank you.